Chapter 3, Section 3.3, Properties of Logarithms. In this section, we'll cover three properties of logs. For m greater than 0 and n greater than 0, we have three special log properties. So looking at positive values of m and n, we have first log base b of mn equals log base b of m plus log base b of n. With this first property, we have the log of a product of two things, the product making up our argument. We can separate that argument, m times n, into two separate logarithms using addition. So we have log base b of mn equals log base b of m plus log base b of n. Just below that, the second property, we have log base b of m divided by n. This equals log base b of m minus log base b of n. So if we have the log of division of two terms, mn, we can break it apart into two separate logs using subtraction in between the two. So log base b of m divided by n is equal to log base b of m minus log base b of n. The third property, log base b of x to p raised to the p power equals p times log base b of x. This property allows us to have an argument where we have a variable raised to a power, and this allows the power to be moved out in front of the logarithm. So these are the three properties of logs that we can use. To the right, we've shown the equivalent log properties using the natural logarithm ln. So if we have the ln of mn, that's equal to the ln of m plus the ln of n. Next, the ln of m divided by n is equal to the ln of m minus the ln of n. And third, we have the ln of x to some power p, which is equal to p times the ln of x. Again, the power p can be moved out in front of the log. We can use these properties to expand logarithms or to write them as a single logarithm. In the next couple of sections, we'll actually be solving exponential and logarithmic functions, and we'll be using these properties to help us out. Let's take a look at expanding logarithms. In part A, we have log base 5 of AB. Notice we have the log of a product, which resembles property number 1 from the previous slide. That property tells us that we can expand this or break it apart into two separate logarithms using addition. So we have log base 5 of A plus log base 5 of B. And we've expanded it using property number 1. No other properties are visible, so we're done with the expansion, and that's our final answer. Part B, we have log base 3 of P divided by Q. This one resembles property number 2, where we have log of division. That second property says we can bust apart the division using two separate logs with subtraction. So that's going to equal log base 3 of P minus log base 3 of Q. Notice we just carry the base of 3 with us as we do the expansion of the logs. No more properties are visible, so we're done, and that's our final answer. Log base 3 of P minus log base 3 of Q. Part C, log of xy divided by z. Notice since there is no base indicated, it's understood base 10. So we have log xy over z. We'll start with the division, because overall we have log of division. So we'll separate that division using property number 2, subtraction. So that's log of the top, xy, minus log of the bottom, z. We notice with log of xy, we have property number 1, that's the log of a product, so we can break that further down as log x plus log y, and then bring down the log z that we got from property 2. So our final answer is log of x plus log of y minus log of z in our expanded form. So we had two properties involved in that one part. Part D, we have log base 6 of r squared over 36. Again, we have the log of division overall, the log of division. So we're going to use property number 2, which says we can break that apart into the subtraction of two separate logs. So that's going to be the log base 6 of the top, which is r squared, minus log base 6 of the bottom, which is 36. That's property number 2. We notice we have r to the power of 2, Well, we can use our property, which involves the power. That's property number 3, and which allows me to bring that 2 power out in front of the log. So that's 2 log base 6 of r minus 6, because log base 6 of 36 is 6. So we were able to simplify that last log in our expanded form. Log base 6 of 36 equals 6. So if it can be reduced, we will do that. Part E, we have the ln of x squared divided by yz. Again, we have the ln of division. This is going to be property number 2. That's the ln of the top, which is x squared, minus the ln of the bottom, which is yz. Next, we can incorporate the power property, and I can bring that power of 2 on x out in front of the ln. So that's 2 ln of x minus the second ln that we have, ln of yz, can be broken apart using property number 1. I can break that product into addition of 2 logs. So that's going to be minus parenthesis ln y plus ln of z. I'm subtracting that entire expansion, so I have to have parentheses around that expansion of ln y plus ln of z. From that point, I can then distribute my sign. So I have 2 ln x minus ln y minus ln z. I would accept either answer on the test, either with the parentheses or with the sign distributed. However, in my math lab and in the textbook, the homework is going to go ahead and distribute that sign. So we'll want to do so for practice, so that we can submit the correct answers in those 2 locations. Part F, we've got log base 2 of 8 over the cube root of x. Again, we've got log of division, which is property number 2. So I can break that apart using property 2, subtraction of 2 logs. So I'm going to have log base 2 of 8 minus log base 2 of the cube root of x. That's the log of the top minus the log of the bottom. From there, I don't have any properties to deal with roots or radicals, but I do know that the cube root of x is equal to x to the 1/3 power. So for my next step, I have log base 2 of 8 minus log base 2 of x to the 1/3 power. I do not have a property dealing with radicals, but I do have a property dealing with powers. So to rewrite that as a fraction power allows me to use the properties of logs. Log base 2 of 8 can be simplified to 3 minus, I'm going to bring my 1/3 power out in front using property number 3 times log base 2 of x. So I have 3 minus 1/3 log base 2 of x. I can simplify log base 2 of 8 as 3, and in the second log I've got the 1/3 that comes out in front of the log. Part G, I've got the ln of the 4th root of x plus 3. I can rewrite that radical as a fraction power as we saw in the last example. So that's the ln of x plus 3 to the 1/4. Now I have the ln of an argument to a power. So I can bring that power out in front. So that's 1/4 ln of x plus 3. I no longer have a power, a product, or quotient to expand. So that's my final answer. That's not ln times x plus 3. That's the ln of x plus 3. So I will not be multiplying and distributing an ln. That's not allowed. Part H, log base 2 of 16a divided by the square root of 5 minus b. I've got the log of division, so I'm going to bust that apart into 2 separate logs using subtraction. That's property number 2. So I have log base 2 of 16a, which is the top, minus log base 2 of the square root of 5 minus b, which is the bottom. Log base 2 of 16a, that's the log of a product, so I can bust that apart using the addition of 2 logs. So my next step would be log base 2 of 16 plus log base 2 of a. I can then bring down the minus log base 2 of 5 minus b to the 1/2. We can rewrite our square root as 5 minus b to the 1/2 power. Again, we have no properties dealing with radicals in our logarithms, so we have to rewrite them as fraction powers. So we have log base 2 of 16 plus log base 2 of a minus log base 2 of 5 minus b to the 1/2. Last, we can simplify. The log base 2 of 16 is 4 plus log base 2 of a minus, we can bring the 1/2 out in front using property number 3. That's 1/2 log base 2 of 5 minus b. I have no more logs to simplify. I have no more logs of products, no more logs of quotients, and no more logs involving powers. So once I've dealt with all of those properties, I've expanded the logarithm as much as possible. So what about going the other direction? How do we write logarithms in terms of a single logarithm or a single log? Let's look at example A. We have log base 3 of x plus log base 3 of y. In this case, I've got the expanded form, but I want to put it back together in terms of a single log. So using property number 1, which says if I have the log of x in this case plus the log of y, I can bring those two arguments together in terms of a product. So that's log base 3 of xy. So addition of two logs with, of course, the same base can be written as one single log as a product for the argument. So that's log base 3 of xy. Part B, we have log base 2 of c minus log base 2 of d. Here I have subtraction of two logs, which is property number 2. And we know to go backwards and write it as a single log, we're going to take our arguments and divide them. So that's log base 2 of c divided by d. So we're just undoing the expansion that we did on the last examples. Log base 2 of c over d. Notice we're writing it as a single log. We're not writing log base 2 of c over log base 2 of d. That's totally incorrect. It's a single logarithm, so make sure you pay close attention to the instructions. We've got log base 2 of c over d. Part C, we have 3 ln of p minus 4 ln of q. Well, I do have subtraction of two logs, but I have coefficients out in front of them, and my properties do not. So I have to get rid of the coefficients out in front. Property number 3 will allow me to do that before I can combine the subtraction of two ln's. So I'm going to bring my 3 back in terms of a power of p, and my 4 back in terms of a power of q. So my first step will be ln of p to the third minus ln of q to the fourth. Now I have the ln of an argument minus the ln of an argument. So I can now combine that subtraction of two ln's into a quotient involving a single ln. So that's going to be the ln of p to the third divided by q to the fourth. So again, undoing that expanded form and putting it back together as a quotient of those two arguments. Again, writing it as a single log or ln. Part D, I have 1/5 log of 2x plus 1. Again, I can move the 1/5 coefficient out in front back into the power position on the argument. So that's log of 2x plus 1 all to the 1/5 power. And then I can rewrite that 1/5 power back in radical form. And we typically do write it in radical form, not fraction powers when we write it back as a single log. So putting it back in radical form, we have log of the 5th root of 2x plus 1. On the test, I'll take the fraction power form or the radical form, but my Math Lab in the textbook, your answers need to be in radical form, and they do indicate that as you submit your answers. So make sure you put them back in radical form as you're submitting homework. So that's log of the 5th root of 2x plus 1. I have no more powers, no more products, and no more quotients to put back together, so that's our final answer. Part E, 4 log base 3 of p minus 3 log base 3 of q plus 2 log base 3 of r. Notice I again have coefficients in front of my logs that have to be moved, and I'll use property number 3 to put those back as powers. So that's going to be log base 3 of p to the 4th minus log base 3 of q to the 3rd plus log base 3 of r squared. I cannot combine logarithms using my properties as long as coefficients are out in front of them. The coefficients must be moved back into the power location using property number 3. Now, looking at the first two LOGs that I have, I can combine those. I have the LOG minus an LOG, so I'm going to combine that using division. So that's log base 3 of p to the 4th divided by q to the 3rd. Again, that's property number 2 that says if I have a subtraction of two logs, I can write it as a single log using division. So log base 3 of p to the 4th divided by q to the 3rd. I'll bring down the plus log base 3 of r squared. Now I have the log base 3 of p to the 4th over q to the 3rd plus log base 3 of r squared. So that's a log plus a log. I can combine that as a product according to property number 1. So that's log base 3 of p to the 4th times r squared over q to the 3rd. Again, we're writing as a single log, so we're just putting the expanded form back together. Part F, I have 1/2 ln x plus 4 ln of 1 minus x squared. Again, I have coefficients out in front of the ln's. I can't combine ln's as long as coefficients are in front, so I'll move those back into the power position using property 3. So that's ln of x to the 1/2 plus ln of 1 minus x squared to the 4th. Now I have an ln plus an ln, which I can write as one single ln using multiplication, or combining those two arguments as a product. So that's ln of x to the 1/2 times 1 minus x squared to the 4th. Final step, I can rewrite that fraction power as a radical, so that's the ln of the square root of x times 1 minus x squared to the 4th power. Again, we're taking these fraction powers and write them back in radical form when we write them back as a single logarithm. This entire section deals with these three properties of logs, either in LOG form or LN form. So for practice on these three properties, either expanding or writing as a single log, we'll go to coursecompass.com, Chapter 3, Section 3.3 homework. Textbook homework is on page 421, problems 1 through 33 odd, 41 through 65 odd, and 71 through 78 all. Again, this is practice of expanding logarithms using the properties or putting them back together as a single logarithm using the same properties.